Okay, so today's lesson is 7.6, Population and Samples. So the objective of the lesson is to compare data from samples to data from population and evaluate claims based on samples. Here are your vocabulary words. Population. So you're going to find these vocabulary words on page 354. So you have population, sample, and random sample. So population is an entire group of objects or individuals that is considered for a survey. So population is an entire group. So let's say students that go to Los Cerritos, that is a population. If I talk about students that are in my classroom, that is a population. It's an entire group of individuals that are considered for a survey. A sample is part of a population. So if we were talking about students in Los Cerritos, and then a sample would be students that I have, because every student that goes to Los Cerritos does not have me. So the students that I have would be a sample of the population of students that go to Los Cerritos. A random sample is that each member of the population has an equal chance of being selected. So random sample means that if I put all the students' name in a bag, and I just, without looking in the bag and looking at the name, I just choose one randomly, then that's a random sample. Everybody in the classroom has a chance of me picking that name. So random sample is that I'm not choosing like every fifth person, or I'm not choosing only boys. It's just everybody has a chance of being picked. That's a random sample. Okay, let's look at example 1. It says, for each situation, explain whether it makes sense to use a sample. So it says the manager of the store wants to know the average age of the store's customer. Think of the manager of the store. So we're going to change the store to, let's say, Vons. So think about how many people come in and out of Vons. That's a lot of people. But the manager wants to be able to know the average age of the customers. So the entire population is too large. There's a lot of people that come in and out of Vons. It would be difficult to find the age of every customer. It does make sense to use a sample. So there's no way for the manager to stop every single customer and ask them what their age is. That would include children, adults, and babies. So what he would do is he would take a sample. Maybe he would choose like every 100th customer and ask them what the age is. Or he might take every 5th, or he just might randomly choose different people. It's a sample of the people that come in. He's not going to ask every single person that walks into his store. Example B, the manager of the store wants to know the average salary of the store's 8 employees. Okay, 8 employees, that is a number. So the entire population is small. Okay, 8, you can ask these 8 people how much they make. Or I can ask, if I had 36 students, I can ask 36 students how much they make. Okay, so where if I had 1 million students, there's no way for me to ask 1 million students how much they made. So it does not make sense to use a sample because every employee can be evaluated. So you can ask every single employee, all the 8 employees, how much they make. So it doesn't make sense to use a sample. Okay, example 2. About 39% of all U.S. households have 2 houseplants. Lee surveys a random sample of households with 2 towns in a state. Compare the samples with the national percent. So really what you're going to be doing is finding out the percentage of town A, town B, and comparing it to the national percent. The national percent is 39%. And so the way you do this is, for each sample, find the percent of the households that have houseplants. So we want to know how many people, what is the percentage of people that have houseplants in houseplants for the town. So the numerator is, it says with plants, this is your numerator. Okay, to find the denominator, all they did was add the 40 plus the 60 to get your denominator. Okay, that's your denominator. So here's your numerator, 40. 40 plus the 60, and then they added, so 40 is the same, and 40 plus 60 is equal to 100. Now understand, this equals 100, but sometimes it's not going to equal 100. So now you have to take this and you have to divide. You have to divide 40 divided by 100. Okay, so put your decimal, 3 zeros. Okay, 100 goes into 400 4 times, which ends up being 400. And you have a remainder 0. So you get your decimal of 0.4. So sometimes it's not going to equal 100, so you have to do this to get your decimal. And then from the decimal, to get your percent, move it over 2 places, and you get 40%. Town B, same thing. What you're going to do is, the with plants is your numerator. Your denominator, you're going to add the 60 plus the 40 to get your denominator. You got 100. Then you're going to divide 60 divided by 100. So 100 doesn't go into 60, put your decimal, and you get 0.6. And to get your percent would be 60%. So now town A is 40%, town B is 60% that have plants in their household. Okay, so the percentage of households with houseplants in town A is 40%. 40% is blank to the national percent. Well, the national percent up here says 39%. So it's close to the national percent because it's only off by 1%. Now the percent of households in town B is 60%. So is 60 close to, far away, or bigger than the national percent? Well, 60 is bigger than 39%, so we're going to write bigger than the national percent. All right, example 3. It says a website consists of 400 pages. A web designer estimates that 60 of the web pages have broken links. In a random sample of 20 pages, 7 of the links have been broken. Determine whether the manager's estimate is likely to be accurate and explain. All right, so you have to set up a proportion to predict the total number of broken links. Usually the first fraction bar is your sample. Look at this. It's your sample. It says in a random sample. Okay, and usually denominator is always your total. Numerator is your part. Okay, so it says in a random sample, so this is your first fraction, 20 pages, that would be a denominator, and part would be your 7. Equals, now these are your links. It says how many pages are there? There's 400 pages, that's your denominator. We want to know how many total links was there. So that's where you get the x over 40. You should know what to do here. You cross multiply. So that's where you get the 7 times 400 is equal to 20 times x. And so 7 times 4 is 2800. Okay, from there, how do we get x by itself? Divide by 20 on both sides. And x is equal to 140. Now look at this. 140 is what is the total number of broken links. But it says the web designer estimates that 60 of the web pages have broken links. Is he close to, too big, or too small on his estimation? Well, I'm going to say the manager's estimate is too small. Because 60 is less than 140.